Alaska's seas are home to a vast diversity of marine life, and its fisheries are among the world's most sustainable, best managed, and most productive. After all, 60% of U.S. seafood comes from Alaska, and that's thanks largely to walleye pollock, the largest U.S. fishery and second biggest in the world. I'm John Sheehan, and this is Dive In with NOAA Fisheries, a podcast about the hard work and sound science that goes into managing and protecting U.S. fisheries. With this episode, we're continuing our kickoff series on surveys, or data collection, by looking at the Alaska region, an area that is, in a word, humongous.
It is quite large. We are responsible for an area of about 1.5 million square nautical miles. That region consists of 5 different large marine ecosystems, meaning that we need to focus differently in each of those areas.
That's Dr. Robert Foy, the director of the Alaska Fisheries Science Center, and someone I was excited to talk to because I knew almost nothing about the Alaska region. And I certainly didn't know, and what we'll hear more about later, is that even small shifts there in ocean conditions or fish stocks can have big impacts, whether on global seafood prices or on tribal communities that depend on those resources for subsistence. And that is what makes the Science Center's surveys vital. Dr. Foy, welcome. Thanks so much for being here. Can you give us a sense of the breadth and variety of your research, of your surveys?
Thanks, John. Yes, so surveys are the tool that we use in order to collect information to meet our mission. We conduct what we call ecosystem-based fisheries management. We are collecting information about the whole water column. We collect data from satellites to better understand what's going on with the physical environment. We collect data from buoys and autonomous vehicles, and in some cases, those are for the oceanography and the physical environment. Now we're starting to collect biological information on those autonomous vehicles and buoys as well. We're collecting information about the plankton, about the carbon in the system. In addition, in order to collect information from larger animals, fish, marine mammals, now we're looking at surveys that are on research vessels, for instance. We have small research vessels working in the nearshore environment on the order of a skiff, and we have large research vessels on the order of hundreds of feet. We also use aerial surveys. We use drones. So you can see we use a number of different techniques in order to capture the information that we need to and survey and monitor these resources.
And what types of information are we talking about? You just cited a whole array of measurement techniques. So what are you gathering?
It's an excellent question, and it depends on the specific survey. We collect information on the ecosystem. That could be temperature. That could be how much plant material or plankton material is in the water that's then going to feed the food that feed the commercial fisheries and feed the marine mammals that are important to us. So those are our ecosystem surveys. We're trying to track the spatial variability, so that's tracking the changes in different areas of the region. We're also trying to track the temporal variability, so the changes with time, with season, or from year to year in how the whole ecosystem works. The second type of data that we're collecting, more related directly to our management mission, is how many animals are out there? How many fish are out there? So we're going into regions and we're conducting surveys for the midwater using acoustics, for instance. That allows us to average the amount of sound coming back, basically a fancy fish finder, and it lets us predict how many fish are in the water column. We put nets on the bottom of the water. We put nets in the middle part of the water. We put nets on the surface of the water, all with the goal of counting what's there and then expanding that up to predict how much is in the entire region. Now, on the other side, for marine mammals, in some cases, we're actually counting individual animals. So from aerial surveys where we use pictures, or sometimes it's just someone looking out the window and counting, to other technologies such as video, where we're able to actually count the number of animals either on the water or on land, and then use that information to come up with how many animals are there.
And so once you have all these measurements, what do those surveys inform beyond just how many fish are in the water?
Great question. And it's not as simple as just how many are there. The end game is to support local economies. It's to support the national economy for the United States. It's to provide climate services for communities and the public. So these data that we're collecting are going to help us from the Alaska Fisheries Science Center provide the science that's needed to make decisions. So for instance, with commercial fisheries, these abundance data and information about how the ecosystem is changing are used by managers. For instance, they're used by the Alaska Regional Office. They're used by the North Pacific Fisheries Management Council in order to assess what we think is there now and then predict what we can take out sustainably. The challenge is we're doing that all with the backdrop of climate change. So that's a constantly changing target.
And can you paint a broad picture of how climate change has been affecting the region? It's really been one of the hardest hit in the world.
Climate change is something we've all been experiencing since the late 1800s because of warming, because of increased carbon dioxide in the atmosphere. There's been a constant progression of impact of climate change on our ecosystem. What has happened more recently is we've had more and more extreme events as a result of that climate change. So not only do we have a very slow process on the order of decades and centuries where we're seeing increased warming, we're seeing decreased ice in the northern latitudes, we're seeing increased carbon dioxide in the water, we call it ocean acidification. Those things are all happening gradually. But at the same time, as they interact with the natural variability in the environment, we see extreme events. For instance, heat waves. We've seen more heat waves in the last decade than we've seen in the last 10 decades. And they seem to be occurring on a more regular basis. And the impacts of those extreme events are very difficult to predict. And it means we need to collect more information to better understand what those extreme events could mean for our overall sustainability of these ecosystems.
And what are you seeing so far? What are the species that are getting affected the most?
So in the North Pacific, we had a real wake-up call with heat waves in 2014-15 and a large heat wave in 2019 in particular. And what these events did was change the thermal structure of the water column in the whole North Pacific, Gulf of Alaska, Bering Sea, and north. And that heat stayed in the water for a number of years, even past what we called the heat wave. That heat stayed in the water. So with increased heat, now animals that are ectotherms, meaning they're the same temperature as their environment, are warmer. They require more energy. So the system is changing. More energy is needed. More prey might not be available. So we saw shifts and in some cases collapses in the trophic structure, in the structure of how the ecosystem works. The first example we had was with cod in the Gulf of Alaska. The cod stock had a dramatic decline right after the heat wave. We were able to pinpoint the source of that decline back to the availability of prey and then the loss of cod for the commercial fishery. More recently, we saw extreme shifts in migration. We saw cod and pollock stocks migrate over 1,000 kilometers within 12 to 24 months of the heat wave. That wasn't necessarily due to prey availability. That was due to the physical environment.
Just a heads up, we're going to learn more about what makes the North Bering Sea so unique and important a little later in the episode. Stick around.
Let me give you the final example, and that is in what we saw this past year. As a result of changes in the ecosystem, largely stemming from the 2019 event, we saw precipitous declines in our crab stocks. a very large decline in our snow crab stock between 2019, 20, and 21. We've also seen some declines in other stocks, such as Bristol Bay red king crab, which also closed this year as a result of low abundance in biomass. Again, associated with these changes that we see in the environment, which is all driven by this overarching climate shift.
Yeah, I saw a news story from October of 2021 in Seattle where crab prices hit an unprecedented high and everyone was freaking out.
If you're craving Alaskan king crab, brace yourself. Prices are at an all-time high.
Boy, I'll say they've never seen crab prices so high, and you were quoted and said basically, yeah, it's climate change. And you said, we're experiencing extreme events that we can't predict, so it's affecting the entire marine ecosystem, which is sort of a plain answer, but it's also humongous and terrifying.
Yeah, absolutely. It is scary. And it may be a little counterintuitive to think that changes or decreases that we see in the abundance of our stocks lead to negative or positive, depending on how you look at it, changes in the economics of these fisheries. So, for instance, the high prices for crab may mean that distributors and fisheries are able to recoup some of the losses because of the decrease. But what it means is that a large majority of the public can't afford the resource. So it's a constant balance of producing seafood, providing protein to the masses, to the world, in a way that is sustainable and affordable, but at the same time making sure that people can make a living. We depend on the small communities. We depend on the production and the canneries, for instance, the communities that support those canneries, and we rely on those larger industries to provide all of that. So it's a complex system where when you see a change, it has downstream effects, either on businesses, individual livelihoods, all the way to prices at the Seattle fish market.
And as you alluded to, there's this tension between you have these changes that have very big economic impacts on the fishing industry, but then they have very consequential and dire effects on the local communities that rely on subsistence fishing.
Absolutely. So that's another challenge that we face, is that the stakeholder for us ranges everywhere from $1 billion industry all the way down to a single family on the Yukon trying to feed their family. And what that means is that we have to be incredibly diligent about collecting data on surveys, monitoring the ecosystem in a way that informs us to how to sustainably manage the large fisheries and what it means to local communities.
And I know during the pandemic, it was especially hard to work with some of those coastal communities. You just couldn't take the risk of going into them and potentially exposing them to COVID. How else did the pandemic throw your operations for a loop?
Yeah, thanks for that question, John. COVID-19 was extremely challenging, continues to be extremely challenging, but especially at the beginning when we knew we had a mission to accomplish. We know that we need to collect data every single year in order to successfully manage these fisheries. And in 2020, in order to maintain the safety of our staff, in order to maintain the safety of the communities, we did our best to collect data, but we had to stand down from a number of our surveys throughout the Alaska region. The result of that was more uncertainty in the management process. So we did everything we could to mitigate that. We worked with partners in the state of Alaska. We worked with partners in the industry. We even went as far as putting uncrewed drones on the ocean. We sent them from California to Alaska to collect what data we could. Now, was all of that perfect? No. But what it did is allow us to get through that year. It allowed us to get to a point in the pandemic where we could put controls in place, again, to keep our staff safe, to keep the communities safe. And now we're back up near 100% in terms of our survey data footprint in Alaska, data collection in 2021, and our expectations for 2022 to cover our most important core regions, our highest priority surveys, and again, do it in a safe manner.
Can you talk a little bit about the difference between the data you collect from a drone versus having someone on the bow of a ship?
Yes, it's quite interesting to see how the pandemic has helped promote our need to innovate. We've always looked for different ways to collect information. But what the pandemic did was highlight the need to be able to be flexible and nimble in providing some of those innovative solutions. So with the drones that we put out in 2020, those drones were able to go and they had the fancy fish finders on board that I mentioned, where they were able to provide us that return signal from what's in the midwater part of the ocean and give us estimates of pollock in particular. Pollock's the largest fishery in the country. We have a real need to understand the variability from year to year because even slight changes are a large change in terms of what we remove from the ocean and what the markets have available to them. So we sent these drones knowing that we would only have those data. What we wouldn't have are the data from the nets. We wouldn't know exactly what size they were. We wouldn't know exactly how many were there based on that size distribution. And the only reason we were really successful, in addition to the incredible, talented, innovative analysts that we have at the Alaska Fisheries Science Center, is because we were focused on that single species. Most of the time, these technologies will help us, but they are unlikely to completely supplant the need to be out there on a vessel to collect biological data, put our hands on fish, see the marine mammals, and survey these resources.
That said, do you anticipate using, now that you've learned and had this learning experience of having to go through innovation and employing uncrewed vessels and I assume aerial drones, are you going to keep using them?
We do. We do intend to keep using them and build out that technology. In fact, we're funding a number of research and development projects this year in order to continue that effort. What the last couple of years taught us is that it's possible. There was still uncertainty, but it let us know that we can employ these types of tools. What it will allow us to do is expand our footprint. So we're working with drones on the surface of the water. We're working with our academic colleagues and our state colleagues to use drones that go under the water. We're using aerial drones to help with the marine mammal counts in the types of estimates, surveys that we can do from the air. And all of that allows us to expand our footprint. So if we have a vessel out there with people on it, with nets, and we're collecting biological data, but we can send out a fleet of drones to also provide information relative to where we are with that ship, that can only make the amount of data that we have better.
Yeah, and obviously the scope of your work is just increasing. What's the way forward? What is your new normal?
Well, the new normal is probably continual change. What we've realized is that we have to continue to support the surveys that we've conducted for decades, and we also need to be more nimble moving forward. There's a constant discussion going on in terms of whether we keep those long-term time series going and how we then pivot and move into new regions as they become available or collect data in a new way. And the truth is, it's somewhere in the middle. We need to proactively consider how and which long-term time series we keep. Some of them might not be relevant any longer because the baseline is changing. Others, you want to keep collecting because it's that changing baseline you want to be able to track. It's clear that with these expansions, with the increased complexity, it's going to be difficult to do it all. We can't be everywhere. So we also have to be more nimble. We have to be able to move, for instance, in the Alaska region, we have to be able to move into the northern Bering Sea, where we only collected data in that region once every decade. Now we need to do it every year. We have to be able to provide ranges of information to our managers, to the commercial fishing industry, help communities understand what we think is coming, and all at the same time, work in that additional complexity where we have fisheries moving into other areas. So now you have more complex interactions between small fisheries, large fisheries, coastal indigenous communities, all overlapping in areas and in ways that they never had before. So again, the way forward is dealing with these complexities by collecting, monitoring, and continuing to build out these surveys, which really are at the core of our mission.
Dr. Robert Foy, thanks so much.
My pleasure.
Dr. Robert Foy is the director of the Alaska Fisheries Science Center. I want to get back to something that Bob touched on earlier, namely the North Bering Sea. This is the body of water east of the Gulf of Alaska, and that sits right between the U.S. and Russia, just south of the Chukchi Sea.
Historically, we didn't think the Northern Bering Sea was terribly important as an area for us to survey because it was its own unique ecosystem. It was very much kind of an Arctic ecosystem.
That's Dr. Lyle Britt, the director of the Resource Assessment and Conservation Engineering Division at the Alaska Fisheries Science Center.
However, a lot of the changes that we're seeing associated with ocean warming and climate change are really happening there first.
In 2010, the Alaska Fisheries Science Center conducted the first standardized survey of the North Bering Sea. At the time, subarctic fish stocks like walleye, pollock, and Pacific cod just weren't there. But when scientists returned to the region in 2017,
things were strikingly different. In fact, the Pacific cod was probably the most striking. We went from very few to basically like an 1,800% increase in the Northern Bering Sea. Roughly 50% of the Pacific cod stock had moved north into the Northern Bering Sea region. About 30% of the walleye pollock stock had moved north into the Northern Bering Sea region. And conversely, more Arctic fishes, things like Arctic cod, capelin, effectively dropped over 90% in those same regions.
Can we talk a little bit about how sea ice and its sort of melting and forming has been so key to the ecosystem?
Yeah, Bering sea ice, seasonal sea ice, has a really dynamic and important role in how the ecosystem functions. Basically, as we go into the winter and temperatures cool, ice on the surface of the water starts to form, and one of the big things that is really critical to the Bering Sea ecosystem is that as that ice is forming, ice algae will associate with the ice. Once spring would hit, that ice would melt and retreat back. And with that melting, all of that algae gets released into the ecosystem. This is a huge amount of energy that would then cascade down and provide resources, a lot of energy into the system. This is one of the things that makes the Bering Sea really unique, because there's also the continental slope where we get upwelling, which also brings nutrient-rich water from mid-depth up towards the surface, which can also, once the ice is gone, result in plankton blooms and additional energy to the system. So unlike other parts of the world, essentially the Bering Sea gets to double dip on these kind of large productive events that can power that ecosystem. That lack of sea ice has reduced that ice algae that cascades down, reduced energy from the system, and has an impact then on essentially that cascading food web. The other aspect that's really important with the sea ice is the cold pool. This really dense, super cooled, briny water that settles near the bottom. And for subarctic fishes that don't tend to like to enter that water that's very, very cold, it's effectively a barrier. So with the recent lack of seasonal sea ice extending down to the southeastern Bering Sea, that barrier no longer exists. And so now we're seeing fish spread across the southeastern Bering Sea and showing up in the northern Bering Sea region and potentially even further north.
Which has huge implications for a very economically important fish stock?
Well, yes, very much, for a host of reasons. One very simple one being, say, for trawl fisheries, the northern Bering Sea and the North Arctic are not open to fishing. So those portions of the stock are now effectively removed from the fishery. Not to mention the ecosystem impacts that we're still trying to understand of fish moving into a region that historically they've not been in large numbers.
And so what has been the Science Center's response to this?
I mean, it's an alarming trend, and so we're trying to get out in front of it as much as we can with the resources that we have available to us. When the Northern Bering Sea survey was first proposed, it started out as a biennial effort. We would go every other year. It's effectively became an annual survey since. We're also working heavily to figure out ways to increase our survey footprint on a more regular basis into the Chukchi and even the Beaufort Seas further north, to understand the ecosystem effects that are happening there as well, and just really how far of a northward movement we're experiencing with these stocks. We've talked mostly about ecosystem and stock assessment surveys. Those are really powerful seminal tools that we use to kind of understand the current status of the animals in a region. They don't tell us necessarily why that status has changed. We really rely on what we consider to be our process surveys or process studies to understand the critical natures of how we got to where we are now. What are the why questions? Why have pollock moved? Why are pollock spawning at a different time? A lot of that comes from our process surveys. These are really critical for our understanding of what's actually happening in the ecosystem.
Dr. Lyle Britt is the director of the Resource Assessment and Conservation Engineering Division at the Alaska Fisheries Science Center. On our next episode, we'll head south from Alaska to the West Coast and hear about the unique features and challenges of the Southwest and Northwest Pacific, and talk about one of the longest-running surveys ever and how it's advanced our understanding of the ocean. Follow or subscribe to us wherever you find podcasts. I'm John Sheehan, and this has been Dive In with NOAA Fisheries.